Okay, so in this video we are going to solve an ideal op-amp with two different voltage sources. Since we know it's ideal, we can assume that Vn is equal to Vp, or that V minus V negative is equal to V plus V positive. And we'll write that down here. Okay, so what is Vp? Well, Vp is 2 volts. So 2 volts is equal to Vn. Right. So now that we have Vn, we can do nodal analysis right here. Okay, so our reference node is going to be Vn, or the node that we subtract everything from is going to be Vn. So we're going to say that 2 volts minus 6 volts, because we have 6 volts here, over 1k ohm. So that's 2 volts, right? Subtracted by 6 volts over 1k, right here. Okay. To that we're going to add the other side here, and we can assume we don't have a current here. There's no current going in or out of these inputs to the op-amp. Alright, so we are going to have 2 volts minus what we're looking for, the voltage drop here, minus V naught or V0 or whatever you want to call it, over 4k. And that is going to be equal to 0, since this is KCL, which basically states that all currents entering a node must sum to 0. So once we have this equation, which I'll rewrite here, 2 minus 6 over 1 plus 2 minus V naught over 4 is equal to 0, we can then just solve. So we have essentially -4 over here, since it's over 1, plus, we'll call this 1/2 minus V naught over 4. That's equal to 0. So now we have -4 plus 1/2 is equal to V naught over 4. Okay, and to solve for this, we'll multiply this by 2. So now we'll have -8 over 2 plus 1/2 is equal to V naught over 4. Well, we can now add these up, so we have -7 over 2 is equal to V naught over 4. Come over here. All we have to do now is multiply both sides by 4. So we'll have -28 over 2 is equal to V naught, and that is -14 volts is equal to V naught. But you can see that these two rails here are limiting us to 10 volts, right? So the voltage is going to saturate to -10 volts. And we're done.